In this video, we are going to go over a simplified way to understand the concept of nystagmus, which is commonly seen in patients with vertigo. Nystagmus. Before we can dissect how nystagmus works, we must first understand how the eyes cooperate with the vestibular system while our head is turning in space. Vestibulo-ocular reflex that allows us to keep our gaze fixed on the same point in space while our heads twist and turn. The anatomical portion of the vestibular system that is responsible for this reflex is called the semicircular canals. A set of them exist in the inner ear on each side of our heads. The semicircular canals communicate with neurons that will form the vestibular branch of cranial nerve 8. At rest, there is a baseline level of firing of these neurons at a smooth, constant rate. When we begin to turn our head to the right, the fluid inside the semicircular canals is displaced and signal to the adjoining neurons that we are turning. The key to understanding all of this is that it is not the absolute amount of firing of these neurons, but the relative difference between the left and right sides during different motions that determines what happens with the eyes. The side we are turning towards, the right, becomes excited, while the side we are turning away from, the left, becomes inhibited. So in our case, the eyes will slowly turn to the left, and the eyes remain focused on the same point in space. Then as the head continues to turn to the right, again, the eyes will slowly turn to the left until they run out of room again and quickly jump to the right again. These slow and fast phases of eye movements will be helpful to us as we try to localize the problem in a patient with nystagmus. Imagine this time that the head stays fixed in place and the semicircular canals on one side of the head, the right side, become activated on their own, in the absence of head turning. The right side becomes excited, while the left side stays the same. Remember I said that all that matters is the relative difference between the two sides. If the right side is activated, while the left side remains the same, there is a net excitation on the right side, and a signal is sent to the eyes that the head is turning, when in fact it is not. What will happen to the eyes? The eyes will slowly turn to the left, and then rapidly turn to the right. Slow to the left, fast to the right. These involuntary eye movements are called nystagmus. Patients with vertigo describe that the world around them is spinning. This is caused by nystagmus of their eyes that is directly related to a unilateral problem with overfiring of the neurons attached to the semicircular canals on one side of the head. If there is a problem resulting in overfiring on the right side, and the head thinks it is turning to the right, the eyes will slowly move to the left and then quickly jump to the right. A way to remember this is that the fast movements are pointing you to the side with the problem. There are actually 3 sets of semicircular canals that balance our gaze in all the possible ways our heads can move in space. This video was only to help medical students understand what causes nystagmus and how it can be localized if you see it in patients. Thanks for watching.